Good morning, Tehmina Khan is here, and today I have come with the explanation of the topic sampling and estimation. It is a topic of S2 A-level mathematics, and I will follow the same procedure. First, I will explain the requirement of this syllabus, CAIE exam, and then I will take examples or the questions from the past paper to explain each concept. And here is the link of the blog on which I have put up all the videos link. So if you want to see my videos, you can go to this blog address and you can find my videos over there. Okay, so let's start. Detail. I will not go into much detail because it might confuse you. So I will talk in short terms. So we should know the difference between sample and population. We should understand when we use random numbers to produce random sample and how do we use it. We should understand what is the meaning of sample mean and distribution of sample mean. We will go into the detail of all this in a while. And then we should know that if the population is normal distribution, then the sample mean distribution will also be normal. You might not understand what I'm talking about right now, but when I'll start explaining with the help of examples, you will get it. Then we will also study what is central limit theorem and when it is appropriate to apply it. We will study unbiased estimates of the population mean and variance, and we will see confidence interval for population mean and confidence interval for population proportion. So what are the cases which are covered under these? We will see in detail later. So let's start with the distinction between sample and population. Okay, so first of all, what is a population? Now, before I explain, I will tell you here once again, which I have explained in my earlier videos also, that I mostly write things down here, and rather than just reading them, I try to explain them. Reason is everybody has a different learning style. Some people learn better when they read, and some people when somebody explains it to them or talks to them. So that's why I try to explain whatever I write as well. So what is the meaning of population when it is used in statistics? Usually what comes in people's mind is number of people and people itself when we talk about population. But in statistics, the population is basically referred to a particular group. Now that group could be students in a class, students in a school, people in Karachi, soft drink cans which are produced in a factory, height of trees in a forest. So whatever you are talking about, the group, that group is called population. Census. Now, like I said, students in a class or students in a school. If in a survey I go to each and every student and whatever questionnaire we are getting it filled, and I get it filled from each and every student in the school, then it is called census. It means you approach to each and every member of the population. Whereas sample is that you collect information by taking a small part of the population, and that information will represent the information of the population basically. That population is just like this. So sample is usually time saving and definitely cost is also effective because it is not taking too much, you do not spend too much money to calculate things. Otherwise, when you go to every member of the population, it takes time, it takes money and everything. But the question is how we will ensure that the sample we are collecting is actually representing the whole population, right? So let's see how do we take care of it. Okay, so the word random sample comes over here. When every member of the population has equal chance to be picked up, when you are getting a sample from the population, every member should have equal chance of being selected. So it is called random sample. and all sample size, because suppose I am selecting from a school from each class maybe 4 students, so this is my sample size. So each sample size have equal chance of being selected. So this is called random sample, and in this context we will see that if you have to select a random sample using random number table. Now what is random number table? We will see in this example. So I will select a sample and the method will be random number tables. There are very many methods, but in our syllabus we will cover random number table method, right? Now see what it is about. For example, you have a population of 500 students and you want to select, for example, 3 students from 500 students. Then first of all you will give one unique number to each student. So for example, student number 1 has number 001. Second student has number 002. Now why I am saying 002? Why not just 2? Because I have to go up till 3-digit number. The moment I will reach to the 100th student, his number will be 100. So that's why all number I will call in 3 digits. So I'm explaining again that I have a population of 500 students and I have to select 3 students using random number table. So first thing is I will assign a unique number to each student, and after that this table. In exam, the table of number which is generated randomly is given to you, and you have to use this table to select students, right? So now how you will select it? Because I have to select 3-digit number, so suppose I select 5 to 6, 3 digits, then 787, then 406, then 341, then 918, and so on. Now the question is, if I have to select 3 students, then how will it work? So what I have selected 5 to 6, is it coming in the range I have given numbers to student? Numbers have been given from 1 to 500, and this number which I am getting from this table is 526. So it is out of the limit. It is going beyond this 500, so I'll cross it out. This is not a number which I have assigned to any student. So next number 787. Again I have crossed it out because this number is not given to any student. Then 406. Yes, because it is coming within the limit of 1 to 500. So there is a student who has been given this number. So similarly, after selecting this 406, then I have 341. This is also within the range. Then 918, cross because no one has this number. 610, cross. Then 471. Fine. Here I would like to tell you, when you are selecting numbers from random table, if any number is repeated, you will ignore it. You will go to the next number. And question is saying select 3 students. So you will start from beginning. The first 3 will be your selected students. So this is how we use random table to select a sample randomly of 3 students. Now let's see what does it mean by sample mean, distribution of sample mean, or mean and variance of the sample mean distribution. So first of all, you will see this symbol X and dash on the top of it, which is called X bar. So this represents that you have taken mean of the sample. So let's try to understand with the help of the example. Okay, what is the meaning of sample mean distribution? What does it mean by the mean and variance of the sample mean distribution? Okay, so for example, okay, so the example I have taken, baby's birth weight, right, in any town. So it is noted that the mean birth weight of babies is 3500 gram, and mu represents the mean of the population. So now after that, samples are collected, samples of 9 babies. So we are collecting random sample of 9 babies at a time, and then we will take out their mean, right? So if your samples are large, for example, I am collecting 10 samples of 9 babies each, right? So if you will collect more samples of the same size, then their mean, and you calculate the mean of each and their mean, you will notice that it will not be far away from the mean of the population. This has been calculated, and here I am just informing you that the result says if sample size is large and then you calculate their sample, it will be very close to the population mean. And how it is represented? This E for mean, X bar, will be equals to mean of the population, and it is represented by mu sign. And when we are talking about distribution, it means we have to talk about mean and variance both. Okay, so for standard deviation of all sample means, we have just seen the sample mean, and now we are seeing sample variance. It is represented by variance of x dash, and it is equals to sigma square over n. So your mean will be mu and your variance will be sigma square n when you are talking about sample mean distribution. And you must understand, I'll show you graphically here, if you take more samples, your standard deviation will decrease. In the past paper, it often asks why the standard deviation decreases when you take a bigger sample. So can you think for a minute here why it happens? You know that in normal distribution your variance is just sigma square, and in sample distribution it is divided by n. So if denominator increases, and you are taking 10, 20, 30, 40. So if your n increases, your overall fraction will decrease. And this gives you the value of variance. For a standard deviation, you take square root of it. So you say here, if question says, why does the standard deviation decreases in larger sample? You will say because we divide sigma square by n. That's why the standard deviation decreases. Now let's see it graphically. So what I have just told you, that if the distribution of normal is mean and variance, then for sample mean, which you will represent by this bar, for normal distribution is mu sigma square over n. Let's see graphically what does it mean. If you see these three graphs, the mean of samples of size 2, so it is from the same population, but I have taken here sample 2, size of 2, sample of size 5, sample of size 26. So as I am increasing the sample size, you can see the shape. The standard deviation is getting narrower, closer to the mean. It is spreaded less. It shows more consistency, right? Although all three are representing normal graph, because the sample I have taken here or explaining here that it is from normal distribution, right? And this was the actual graph of the population. Okay, so this was just for the explanation. So now let's see, with the help of a question which I have taken from past paper, that how do we calculate probability for sample distribution. Okay, so the question I have taken is from June 08 and question number 2, and the question says that the length of time people take to complete a certain type of puzzle. So it is about a puzzle. People are taking some time to complete it, and it is normally distributed. So distribution of the population is given to you, it is normal, and it has mean 48.8 and it has a standard deviation 15.6. So two information of the population is given to you. So my random variable x is basically the time taken by the people to complete the puzzle. Right? Now what is question asking? Question is saying the time taken by random sample of 5 people are noted. The mean time x dash is calculated for each sample. So this information is provided to you that you are taking sample of 5 people and you are calculating their mean. Now what it is saying, there are two parts of the question. First part of the question says, state the distribution of sample mean giving the value of any parameters. Okay, so what does it mean? We have just seen how to describe the parameters of sample mean. Let's see here. In the first paragraph of the question, you are told what is the mean and variance of the population, which I am mentioning here. Right? This is about population. You see, I am not putting dash here. I am writing X is the time in minutes taken to solve the puzzle. Okay, so this is my mean and this is my variance. Now this represents of the sample. So this is the mean time in minutes taken by 5 people to solve the puzzle. And now my distribution will be, mean is same, we have just seen that, and variance is same but divided by sample size. So how we will write it? Let's see it. So this is how you will write it, because this was the question. So the earlier part I just did there to explain to you. So question was saying what is the distribution and how you will express it. So this is how you will express. It is, mu we have seen, and this is sigma square over n. So second part of the question was saying find the probability of sample mean when it is less than 50. Right? And you know what is sample mean, what we were talking about here? Do you remember? Yes, time taken to complete the puzzle. So now it is saying what is the probability that the puzzle will be completed in less than 50 minutes. And we remember from the previous explanation of normal distribution that now we are using a standardized table, standardizing it. So now we will change this x bar into z. And this was the formula for normal distribution. In sample distribution, it will be x bar minus mu. This mu will be from population divided by sigma over root n. This is again from the population. So now it will be, I'm changing this into z. Z less than 50 minus 48.8. And if you see here, this is exactly what I have mentioned here. Right? So I'm just picking up mu from here and standard deviation from here. So after that I got my value of z. Now if you see, what does it mean? It simply means graphically that your z value is somewhere on this side because it is plus. So right side of the mean is your z values which are plus, and this side they are minus. So it means this value of z is somewhere here, and I'm interested in the probability which is on the left side of it. So I'm interested in this probability. So from the table I can read, I'm not teaching you here how to read the table, it is a prerequisite. I expect that you know how to read the table. So from the table you will read that the probability written against this value is 0.5683. And we have to give answer in 3 significant figure, so it will be 0.568. Now here I would like to add an explanation which is not actually a part of the question, but I would like to explain it to you because it is often asked in few questions. And for example, question says that if there are 200 samples, each of size 5, right? We have taken the sample of 5 people, and this is the probability of them completing the puzzle in less than 50 minutes. So if I have 200 sample, then how many out of 200 will complete the puzzle in less than 50 minutes? So what will you do in that case? You will simply multiply this probability by 200 and you will know how many samples will complete the puzzle in less than 50 minutes. So this is video number 1. In video number 2, I will continue the explanation of sampling and estimation. So thank you very much for watching it. if you like it, please press the like button and the subscribe the channel and press the bell button so that you get indication whenever I upload my new video. Thank you very much.